Security technology, access controls, firewalls and VPNs. Technical controls utilize technology to mitigate vulnerabilities, encompassing various examples such as encryption, antivirus software, intrusion detection systems and firewalls. Technical controls play a crucial role in enforcing policies for IT functions not directly managed by humans, enhancing an organization's capacity to balance objectives such as ensuring information availability while safeguarding its confidentiality and integrity. Access control systems are built on four fundamental mechanisms, each serving a distinct function. Identification, where users are recognized within the system by factors like ID numbers. Authentication, allowing users to verify their identity through methods like smart cards. Authorization, dictating the actions users are permitted to undertake within the system. And accountability, enabling tracking and monitoring of user activities within the system. Access control approaches encompass various methods through which systems determine who can access a specific resource and under what conditions. Discretionary access controls operate based on the choice of the data user, while non-discretionary access controls are enforced by a central authority. Biometric recognition utilizes unique physical or behavioral traits for identification, including fingerprints, iris patterns, facial features, voice characteristics, and behavioral traits like typing rhythm. Each characteristic offers different levels of accuracy and susceptibility to spoofing, making them suitable for various applications and security needs. A compilation of biometric effectiveness and acceptance ranks from various sources is provided in the table, where ratings are denoted by H for high, M for medium, and L for low. Firewalls in information security encompass both hardware and software components designed to filter or block specific data transmission between external, untrusted, and internal, trusted, networks. They can manifest as distinct computer systems, software services operating on routers or servers, or as separate networks equipped with supporting devices. Firewalls are categorized based on their processing modes, which include packet filtering, application gateways, circuit gateways, MAC layer firewalls, and hybrids, which combine various technologies. Firewalls employ various processing modes for filtering and controlling network traffic. These include packet filtering, which inspects individual packets based on predefined rules, application gateways, or proxies, which filter traffic at the application layer, circuit gateways, which monitor entire sessions for security breaches, MAC layer firewalls, which filter traffic based on MAC addresses, and hybrids, which combine multiple technologies for enhanced security. Each mode offers distinct advantages in protecting networks against unauthorized access and threats. Packet filtering firewalls analyze the header information of data packets, primarily focusing on criteria such as IP source and destination addresses, direction, inbound or outbound, and transmission control protocol, TCP, or user datagram protocol, UDP, source and destination port requests. The IP header contains vital information like version number, length, differentiated services, congestion notification, total length, fragmentation details, time to live, protocol type, checksum, source and destination addresses. The TCP packet format includes source and destination ports, sequence and acknowledgement numbers, data offset, reserved bits, flags, window size, checksum, urgent pointer, and options. The UDP datagram consists of source and destination port numbers, length, and checksum fields. A packet filtering router determines whether to allow or deny packets based on predefined filtering rules, considering factors such as packet header information, example, IP source and destination addresses, and the encapsulated protocol being used, example, TCP, UDP, ICMP, or IP tunnel. Application gateways, also referred to as proxy servers, are commonly deployed on dedicated computers, often situated in unsecured network areas such as the demilitarized zone, rendering them more susceptible to risks from less trusted networks. To enhance security, additional filtering routers can be installed behind the proxy server, providing further protection for internal systems. MAC layer firewalls operate within the media access control sublayer of a network's data link layer, making filtering decisions based on the identity of specific host computers. These firewalls establish access control lists associating MAC addresses with specific types of packets permitted to be sent to each host, while blocking all other traffic. A hybrid firewall integrates features from various types of firewalls, such as combining packet filtering with proxy services or circuit gateways. Alternatively, it may involve two distinct firewall devices, each operating independently but interconnected to function collaboratively. This setup facilitates security enhancements for organizations without necessitating the complete replacement of existing firewall systems. Next-generation firewalls and unified threat management devices are included within this framework. Firewalls encompass various types, including packet filtering, stateful inspection, proxy, next-generation firewalls, and unified threat management systems, each offering distinct security features. Protocol models, such as OSI and TCP/IP, serve as frameworks for networking, delineating communication layers and facilitating network design and troubleshooting. Firewall devices can be set up in various network connection architectures, with the optimal configuration determined by three key factors: the network's objectives, the organization's capacity to develop and implement architectures, and the budget allocated for functionality. Common architectural implementations of firewalls include single bastion hosts, screened hosts, and screened subnets with demilitarized zone. A single bastion host, often known as a sacrificial host, serves as the sole defender at the network perimeter. Typically configured as a dual-homed host with two network interface cards, one linked to the external network and the other to the internal network, this architecture frequently employs network address translation to further fortify against external intrusion attempts. The screened host architecture integrates a packet filtering router with a distinct firewall, often an application proxy server. This setup enables the router to preliminarily screen packets, reducing the traffic burden on the internal proxy. Consequently, for an external attack to breach internal data, it necessitates compromising two separate systems, enhancing overall security measures. The screened subnet architecture, commonly utilized today, serves two primary functions: safeguarding DMZ systems and data from external threats, and shielding internal networks by regulating external connections access to internal systems. A screened subnet, often referred to as a demilitarized zone, typically comprises two or more internal firewalls positioned behind a packet filtering router, with each firewall guarding a trusted network. Connections from external or untrusted networks are directed through an external filtering router. Additionally, connections from outside networks pass through a routing firewall to segregate the network segment designated as the DMZ. Access into the trusted internal network is restricted solely to DMZ bastion host servers. Well-known port numbers are standardized identifiers ranging from 0 to 1023 assigned to network services by IANA. Content filters are software programs or hardware, software appliances utilized by administrators to control the content entering or leaving a network, essentially comprising scripts or programs that limit user access to specific networking protocols or internet locations. Their primary objective is to restrict internal access to external material. Commonly, these filters are employed to prevent users from accessing non-business websites or to block incoming email spam. Ensuring the security of remote connections involves the installation of inter-network connections, typically through leased lines or other data channels, which are usually safeguarded according to formal service agreements. However, when individuals need to connect to an organization's network, a more adaptable solution is necessary. Virtual private networks have emerged as a popular choice due to the widespread availability of the Internet. Remote access to an organization's network, typically via dial-up connections, involves authentication mechanisms such as Radius and TACACS. Remote authentication dial-in user service, Radius, operates through a centralized server, managing user authentication responsibilities, while Terminal Access Controller Access Control System, TACACS, validates user credentials similarly through a centralized server, employing a client-server configuration. In Radius configuration, a remote worker initiates by dialing the NAS and submitting their username and password. The NAS then forwards this information to the Radius server, which evaluates the request and either approves or rejects it while also granting access authorization. Once approved, the NAS allows access to the authorized remote worker. A virtual private network is a private data network utilizing public telecommunications infrastructure to establish secure communication through tunneling protocols and security measures. Often employed to extend an organization's internal network connections to remote sites, VPNs encompass three defined technologies according to the Virtual Private Network Consortium: Trusted VPNs, Secure VPNs, and Hybrid VPNs. Virtual private networks come in various types. Trusted VPNs, also referred to as legacy VPNs, utilize leased circuits from service providers for packet switching. Secure VPNs employ security protocols such as IPsec to encrypt data transmitted over unsecured public networks like the Internet. Hybrid VPNs integrate both trusted and secure technologies, offering encrypted transmissions similar to secure VPNs over some or all of a trusted VPN network. A virtual private network establishes a secure tunnel between either your device and the Internet or two private networks interconnected over the Internet. A VPN tunnel establishes an encrypted connection between your device and the Internet, or between two private networks over the public Internet. Various tunneling protocols facilitate this, including point-to-point tunneling protocol, Layer 2 tunneling protocol, secure sockets layer, and transport layer security. Tunneling is a protocol facilitating the secure transfer of data from one private network to another via public network connections. It involves two key processes, encapsulation and encryption. Encapsulation entails wrapping an internet data packet within another packet, serving to conceal the user's IP address. Encryption, on the other hand, involves encoding information to limit access solely to authorized parties. A remote access VPN enables business users to remotely connect to a private network, granting access to its services and resources. It is commonly utilized by home or private users to circumvent regional internet restrictions and access blocked websites. Site-to-site VPN, also known as router-to-router VPN, involves one router functioning as a VPN client while the other serves as a VPN server. This configuration is commonly used to connect multiple offices within the same company, termed as an intranet-based VPN. Conversely, when companies utilize site-to-site VPN to connect with another company's office, it's referred to as an extranet-based VPN. In transport mode VPN, while the data within the IP packet is encrypted, the header information remains unencrypted. This setup enables users to establish a secure connection directly with the remote host, encrypting solely the data contents of the packet. Tunnel mode VPN employs two perimeter tunnel servers to encrypt all traffic passing through an unsecured network, with the entire client package encrypted and integrated as the data portion of a packet transferred from one tunneling server to another. The main advantage of this model is that intercepted packets reveal no information about the true destination system. Thank you for watching.